Alright, in section 3 and 4, we're finally going to solve by elimination. This is the third and final way that we're going to learn how to solve systems, and I guarantee it will be your favorite. So by the end of this lesson, you should be able to solve systems by elimination, and then also analyze the weird ones, the special types. So remember, there are three possible solutions anytime you solve a system of linear equations. You can get one solution, and remember that's when you get something for x and something for y. And remember, when you graph them, that means that they're going to cross somewhere, so you're looking for that point. Infinitely many solutions, remember we have the same line, so it's just one line on top of each other. Remember, you still get a true statement here, so 3 equals 3. And then no solutions, the lines are parallel, they're never going to cross. You're still going to get a false statement for this one, and that would look something like 0 equals 3, so something that doesn't work. There are three methods to solve them. We have done graphing, you should be good with substitution, so moving on to elimination. Elimination is also called the addition method. It just depends on what book you look at or what resource you look at, but it means the same thing. We're going to add things up and eliminate things all at the same time. So here are your steps. The first thing you need to do is make sure your equations are lined up. We want everything in standard form. Can't spell, standard form. So you want something like 3x plus 2y equals 6 over top of something like 4x minus 2y equals 10. So you got your x's, your y's, your equal signs, and then your numbers. Everybody's lined up. Then you need to either add or subtract equations to eliminate the variable with a common coefficient. So your coefficients are the numbers out front. So if we come back up here and look, we have a 2 and a negative 2. Those have common coefficients, and if we were to add these two things up right here, we would end up with those things crossing each other off. Once you get done with that, you are going to solve the equation for whatever's left over, and then you are going to substitute your answer into the original equation and solve for the other variable. So remember, you need an x and a y here. The first thing that you solve, you're only going to get one of them, and then you got to substitute and solve again. So first step, make sure your equations are lined up. We have x's, we have y's, we have equal signs, and we have numbers. Everything's lined up. Now the next thing it says for us to do is either add or subtract to eliminate the variable with the common coefficient. So if we look here, I have positive 6y's and negative 6y's. If I take my two equations and just add them together, I'm going to combine my like terms. 5x plus 3x gives me 8x's. Negative 6y plus 6y gives me 0 here. I have the equal sign. And then negative 32 plus 48 gives me 16. Now if you look, this leaves me with a really super easy equation to solve, and it only has x's in it. So if I divide both sides by 8, I get x equals 2. Now this is where we solved for one equation for the remaining variable. Now we got to plug that back in and solve for the other one, just like we did with the substitution. So I'm going to take this, and it doesn't matter what equation I plug it into. Let's plug it in the first one just because it's first. I'll have 5 times 2, because that's my x, minus 6y equals negative 32. If we do some algebra here, I'll subtract 10 from both sides. Get negative 42, and if I divide both sides by negative 6, I end up with 7. So my answer for this one is x equals 2 and y equals 7. Remember, just like for substitution and graphing, you can always check your answer. Plug it back in, see if it works out right. So let's try this next one. First thing I gotta look at, are things lined up? I can already see I have this equal sign here and this equal sign here, so they are not lined up. I want to put these both in standard form. So the second one is in standard form. I'm just going to rewrite it. I'm just going to leave it. So this. But this one, I need to move the 3y over. So I'm going to subtract it from both sides, and I get the 6x. Now it's minus 3y, and now it equals just 3. So now I have all my equations lined up, and I now have a positive 6x and a negative 6x. So when I go and I add these together, these are going to cross each other off. Negative 3y plus 5y gives me 2y, and it equals 3 plus 3, which is 6. Super easy equation to solve. We get y equals 3. And then remember, we got to substitute and solve again. So it doesn't matter what equation you plug it into. Again, I'm going to plug it into the first one just because it's first. The other good reason to plug it into this first one is because x is almost by itself here. If I multiply this together, I get 9 plus 3, which gives me 12. And then all I got to do is divide by 6. So I get 2. So this answer is 2, 3. And just like I said before, you can always check to make sure that it works. So if you notice, for both of these, once we got things lined up, we automatically had things that crossed each other off. We had negative 6y, positive 6y, negative 6x, and positive 6x. Unfortunately, they're not all going to be that easy, but we can make them look like that. So if we take a look at these ones here, and I want to solve for either x or y, I'm going to take a look at my equations once they're lined up. So I got to switch this first one around. So it should say 2x, we'll put that first, plus 3y equals 4. And then my other one's negative 6x plus y equals negative 7. Now this is where you have options. You can choose to either get rid of or eliminate your x's or your y's. And in order to make that happen, you need opposite coefficients. So one's got to be the positive version of the number, one's got to be the negative version of the number, so then when you add them together, they eliminate, they cross off. So I'm going to take a look at my x's here. One of them's 2x and one of them's negative 6x. I can turn 2 into 6 by multiplying it by 3. And in math, we can't just go multiplying one thing by 3. We got to multiply everything by 3. So I'm going to multiply 2x by 3 and get 6x. I'm going to multiply 3y by 3 and get 9y. And I'm also going to multiply 4 by 3. So it gives me 12. So this equation right here is exactly the same as that one. It's just 3 times bigger. But because everything is 3 times bigger, it means the same thing. And now this other equation that I didn't do anything to says I have negative 6x plus y equals negative 7. And now, just like the ones that we had before, when I go and add these things up, my x's will cross off. I'll end up with 10y, and it equals 5. And if I divide both sides by 10, I get 1/2, or 0.5. And then just like before, once I have one of my variables, all I got to do is plug the other one in. So I have 3 times 1/2 plus 2x equals 4. 3 times 1/2 gives me 1.5. If I subtract that from both sides, I end up with 2.5. And if I divide both sides by 2, I get 1.25, or 5/4 if you really want to. So now I can write my answer as 1.25, comma, 0.5. So let's try this next one. So first thing, make sure things are lined up. The first equation needs some rearranging. I have negative 2x plus 15y. Let's move the 32 over here. So it becomes negative 32. And then I have 7x minus 5y equals 17. So then this is where I get to choose. What do I want to get rid of? So if I look at my x's, if I want to get rid of them, I can't turn 2 into 7 and I can't turn 7 into 2. But just like when we were doing denominators, I can turn them both into 14. You can go ahead and do that and get rid of your x's, or you can take a look at your y's. One of them's positive 15 and one of them's negative 5. If I multiply negative 5 by 3, it'll turn into positive 15. So we can end up with 21x minus 15 equals 51. 17 times 3. And then I'm just going to keep this guy the same. I'm just going to bring it on down here, because now my y's will cross off if I add these two things up. So let's add them together. 21x minus 2x gives me 19x. These guys cross each other off, and we end up with 19 here. Super easy equation to solve. We get x equals 1. And then remember, once you find one variable, you got to plug it back in to find the other one. So if I have 7 times 1 minus 5y equals 17. If I subtract 7 from both sides, I get 10. And if I divide both sides by negative 5, I get negative 2. So if I was to graph these two lines, they would cross at 1, negative 2. Alright, almost done. The next ones are our weirds. So remember, get things lined up, add things up, see what you get. So this one, everybody's lined up, but nothing crosses off. If I were to add these two guys together right now, x's or y's wouldn't cross off. So this is where you got to change some things around. So let's get rid of x's because they're first. This is 4x and this is negative 2x. So I got to multiply everybody here by 2 to change it to negative 4x plus 2y equals 6. I'm just going to bring this one on down. Oops, this was positive 4x minus 2y equals 8. Now, if I go and I add these up, something crazy happens. My x's cross off and my y's cross off, so I end up with 0 on that side. My equal sign is right here, and 6 plus 8 is 14. And then just like with substitution, you have to ask yourself, is this a true statement? Yes or no? 0 does not equal 14, so that means this would have no solutions. And if I went to graph this, it's because they would be two parallel lines. So same kind of thing over here. You want to get things lined up, which this isn't, so I'm going to add x to both sides. And then you can actually see that this gives me exactly the same equation. So if you want to, you could go a little further and you could do elimination. In this case, we would subtract everybody. So x minus x gives me 0. 2y minus 2y gives me 0. 10 minus 10 gives me 0. Or you can say, hey, they're the exact same equation, so that means that there are infinitely many solutions. So you have one to try on your own. Remember, you are solving this by elimination. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.